Section 1.4 is called Equations of Lines. In previous sections, you've been given the equation of a line and you've either graphed it or found the slope and the y-intercept. In this section, what you're going to do is you're going to be given points on a line and the slope, and you're going to work backwards to get the equation of the line. And we're going to work with three main equations: the standard or general form of the linear equation, where the x and y are on one side and the constants on the other. And here's an example of that: 2x plus 3y equals 6. The slope-intercept form, y equals mx plus b. And here's an example of that: y equals 2x plus 1. And then point-slope form, which we're not going to use much in this class, but I'm going to show it to you because if you go into instruction in your e-text, this is the way they're going to solve these. The first type of problem you're going to run into is the simplest. We're given the slope of the line and the y-intercept. All you have to do to solve these is look at your slope-intercept form equation. Wherever you see the m for slope, plug in your 2/3. Wherever we see the b for y-intercept, plug in the 5. And we have the equation of a line with slope 2/3 and y-intercept 0, 5. Okay, the second type of problem is going to require a little bit of work. Here we're given the slope and a point is passing through. And there's two ways to solve this: using the slope-intercept form and using the point-slope form. So let's work this both ways. Using slope-intercept form, which is y equals mx plus b, the first thing I'm going to do is plug in my slope for my m. And then I'm going to plug in my 5 and my 9 for my x and my y. And I'm going to solve the equation for b. So 2 times 5 is 10. I can bring it over to the other side. And I get b equals -1. So now, let's just plug that -1 in for the b in this equation. And I have the equation of the line, with slope 2 passing through the point 5, 9. Now let's try it using the point-slope form. And I won't use this form ever again in this class, but this is the way your e-text solves it, so you need to be familiar with it if you're going to study that route. So what I'm going to do here is plug 2 in for my slope, 5 in for my x1, and 9 in for my y1. I'm going to leave x and y alone. Then I'm going to distribute the 2, and I'm just going to remove these parentheses now because they really serve no useful purpose. So 2 times x is 2x, 2 times -5 is -10, and then I'm going to bring this 9 over to the right hand side, and when I do that I'm going to change the sign and then simplify. And I get the exact same answer. So you can solve the equation whichever way you want to. It doesn't matter. I'll be using this one in this class, but if you prefer this method, that's absolutely fine. The most challenging type of problem you're going to have in this section is when you just have 2 points and you don't have a slope. When you run into this type of problem, the first thing you need to do is find the slope. And remember, to do that, we're first going to designate one pair x1, y1, one pair x2, y2, and find our slope. So y2 minus y1 over x2 minus x1 is -6 over -18, simplifies to 1/3. Now I'm going to be using slope-intercept form, and that's y equals mx plus b. I'm going to plug the 1/3 in for the slope. And now I'm going to pick either one of these points to plug in here. And I'm just going to pick the one that looks easiest, and this first pair looks easiest to me. So I'm going to plug 0 in for the y and 6 in for the x. Yep. That should have been a 3, which would make that a 2. So let me rewrite that. Okay, move the 2 to the other side. And I get a b of -2. So I just plug the -2 back into there. And I have the equation of the line passing through these 2 points. You're also going to find these problems written in this form, in function notation. And remember, when you have function notation, it's the same thing as the ordered pairs, where the thing inside the parentheses is your x, and the number outside is your y. So we can rewrite this as the ordered pair 1, 2, and this as the ordered pair 4, 6. And now we should recognize it as the type of problem we've just done. So the first thing we need to do is find the slope. Once again, designate one pair x1, y1, one pair x2, y2, and plug into the formula. So we have y2 minus y1 over x2 minus x1 equals 4/3. So we have a slope of 4/3. And since I'm solving these using slope-intercept form, I'm just going to plug 4/3 in for my m. And now I'm going to plug one of these ordered pairs in for x and y. Just pick the one that looks simplest. This one looks simplest to me. So I'm going to plug 2 in for my y, and 1 in for my x. And when I simplify that, I get this. Now I'm solving for b, so I have to move the 4/3 over to the other side. And I change the sign when I cross the equal sign. And that gives me a b of 2/3. Now I know most of you truly hate fractions. No need to worry about it. If you're using a TI 83 or 84 calculator, if you just enter it in your calculator, you don't even need the parentheses, then hit the math button and enter twice, this will be converted to this fraction. And now I just plug this b in to this equation. And we found the equation of the line passing through these 2 points. Now all we have to do is the third part, find h at 3. And all this really means is plug that 3 in for our x. And when I multiply these together, I just get a 4. And when I add those together, let's see, I just get a 14/3. So written in function notation, h of 3 is 14/3. And again, do not worry about the fractions, just plug this straight into your TI calculator, hit math, enter twice, and you will get this answer. And the last thing we're going to do in this section is the equation of horizontal and vertical lines, as well as their slopes. So let's take this example, the horizontal line through the point 2, 3. Remember, the horizontal line is just your y equals, and all you're going to do is take the y coordinate. So the horizontal line through the point 2, 3 is y equals 3. Slope of a horizontal line is always 0. Now we're going to do the same thing with the vertical line. In this case, the vertical line through the point 1/2, 6. And vertical lines are always x equals. And it's going to be, just like with the horizontal lines, x equals x coordinate this time. Slope of a vertical line is always undefined.